Welcome everyone to our GMAT strategy seminar. My name is David Newland and this seminar is presented by Veritas Prep. Our seminar today is Master GMAT Statistics Questions with the Logical Approach. Okay, so the logic behind statistics questions is something that often does get lost. People tend to focus on the formulas, people tend to focus on the pure math, and what gets left behind is, in fact, the reasoning. So we're going to master GMAT statistics questions with the logical approach. More than ever, GMAT quantitative reasoning section is about reasoning. More than ever, this is about reasoning. Remember, everything on the GMAT has the word reasoning. We have verbal reasoning, quantitative reasoning, integrated reasoning. It's not only critical reasoning. It's not only critical reasoning, right? Everything is reasoning. And as more and more people from around the world study longer and harder for this exam, right? More and more people from around the world. You guys know that more than 50% of the GMAT exams are now given outside the United States. So this is now officially a world exam. So because people are studying so hard for this exam, particularly in certain countries that might be represented in our seminar today, most of these people already know the formulas. You guys know what I'm talking about. If you're coming from a culture or a country where English is maybe not the first language or is a co-language, and you're just not thinking about maybe that 99th percentile verbal, you know that verbal is going to be a little bit of a struggle. You know how many people there are out there who think that verbal is going to be a struggle, and you know what they want on the quantitative. You guys know. People are looking for this on the quantitative section. People are looking for a 51. That's what they want to see on the quantitative section. So how is the GMAT reacting to so many well-prepared people? The GMAT is reacting by increasing the difficulty, by making it more difficult to know when and how to apply the formulas. In other words, they're making it more difficult based on reasoning. They're making quantitative questions harder to interpret. They're making them harder to know immediately what to do, what to apply. So it really is about the reasoning. What does reasoning and quantitative reasoning mean? Well, it's going to mean three things for us today. The first one is definitely reading carefully. Noticing the details. Okay, what does the question ask? What facts are given? What deductions can we make from the question stem? Can we determine that something's an integer? Can we determine that something has to be positive? Any of those type of things. B, knowing the most useful formulas and equations, and here's the big thing, knowing when to apply each one. And then C, we want to have some pure reasoning at the ready. This is for when the formula fails or takes too long, and also as a way to check yourself. Check the result you're getting from the formula to make sure that it actually makes sense. So let's talk about reading carefully and noticing the details. Let's try this data sufficiency question. And listen, we're going to start with a bit of a punch here, okay? This is a good data sufficiency question. We've got 90 seconds here, and I certainly don't mind having you guys put your answer right into the chat box. You know the answers for data sufficiency. You know what those are at this point. So we just have the statements here. You know what the answers are. Take 90 seconds on this, and I'll keep track of that for you. Just take 90 seconds on this and see what we can see on this question number 1. Okay, there's 90 seconds to look at this one. I know it's not a lot of time, and this data sufficiency question requires some work, but let's put more of the explanation into this, and maybe we won't try for quite as much, of you guys working on it. So let's take a look. The Department of Environmental Protection measured the volume of water in 10 similarly sized reservoirs in state X and found the standard deviation was 4 million cubic gallons. Okay, so the standard deviation equals 4 million cubic gallons. Was the standard deviation of those 10 volume measurements lower at the end of the year? Read very carefully the question stem. The question stem is a yes or no question. We want to know, was the standard deviation lower at the end of the year? Did the standard deviation go down at the end of the year? We did get one correct answer on this one out of those who've answered at this point. So was that standard deviation lower at the end of the year? So let's start with statement number 1, which tells us that at the end of the year, the average volume of the water in the 10 reservoirs had decreased by 20%. The average volume had decreased by 20%. Statement number 1 is not sufficient. So we've got a couple of people with answer choice D. Maybe we're not going to have D on this one because, look, the average volume decreasing by 20% is not enough information. On the one hand, the volume of each could have gone down by exactly 20%. And I want to make sure you guys know this rule. If everything in a set is decreased by the same amount, then the standard deviation is also decreased by that amount. So if each of these had been decreased by exactly 20%, then the standard deviation would also be down by precisely 20%. Okay? So if you decrease every one of them by 20%, you also decrease the standard deviation. If you increase everything by 50%, you increase the standard deviation by 50%. However, there's another scenario here, because this doesn't tell us that they all went down by 20%. It says the average went down by 20%. On the other hand, we could have some volumes that have gone up or stayed the same, while others went down a lot. So here's 2 examples. This is the first before the change. Okay, let's just say we had 20, 22, 24, 26, 28, 30. Is that a standard deviation of 4 million? It could be. It could be, right? So the difference goes from an average of 25 down to 20 and up to 30. So, maybe it's a little bit less than 4 standard deviation, but just as an example. If we decrease the average by 20%, we go down to 20. But look, I only decreased the first 3, 10, 12, and 14 instead of 20, 22, and 24. I left the last 3 the same, 26, 28, and 30. And you'll notice that the standard deviation increased. Okay, because I only moved 3 of them, the standard deviation increased. Now we have an average of 20. And now we have the distance between 20 and 30 and the distance between 20 and 10. So now, in fact, we have bigger distances between the numbers. And we do actually have, at this point, a larger standard deviation than we started with. Okay? We have a larger standard deviation than we started with. So this statement number 1 is not sufficient. What about statement number 2? Some of you said answer choice C, right? Okay, but what about statement 2 on its own? Notice how the question is worded. This is a yes or no question. Yes or no questions are more likely to be solved by one statement alone, or each of them alone. This is something I call the ABD alarm, and this is something that I teach in my data sufficiency class. It's too much to go into right now, right? It's too much to go into right now, but in my data sufficiency lesson, I talk about the fact that certain questions are more likely to be answered with less information, and those would set off your ABD alarm. Yes or no questions are this type. Okay, so be careful when you get a yes or no question. Listen, be very careful on this type of question that you explore each statement alone before you put them together. So take statement 2 alone before you put it together with statement 1. Statement 2 alone is going to turn out to be sufficient. The answer to this question is going to be answer choice B. And here's why statement 2 alone is sufficient. With statement 2, we know that each volume decreased by the same amount, right? The percent decrease in the volume of each reservoir was the same. So they each decreased by the same amount. This means they all decreased uniformly, and therefore the volumes came closer together. It doesn't matter by how much they decreased. It doesn't matter by how much they decreased. Look, what if we decrease by 10%? We'll start with 10, 20, 30, 40, 50. That's going to be the numbers we start with. Okay? Obviously, that's not a standard deviation of 4 million. It's just an example. Now decrease by 10%. 9, 18, 27, 36, 45. This is a lower standard deviation. When you increase each term by the same amount, you always bring those terms closer together. You now have a range from 9 to 45 instead of from 10 to 50. So statement 2 is sufficient. We don't need to know how much. We just need to know that they all decreased uniformly. Okay? Remember, this is a yes or no question. When taken together, the statements do tell you that the standard deviation decreased by precisely 20%, because now they all went down by the same amount, and that amount was 20%, right? If we put them together. That makes answer choice C the correct answer if this question had asked for a specific number by how much the standard deviation had decreased. A specific number question, the answer would have been C. But as a yes or no question, the answer was B. Okay, this question only asked if standard deviation did decrease. C is therefore a great trap answer on this particular question. So, reading carefully and also knowing the tendencies and being able to anticipate. Knowing that yes or no questions are often tricky and sufficient when you think they wouldn't be. Now let's try a problem-solving question. I'll give you another 90 seconds on this one. Okay, oh, here we go. We've got some kind of a table on this one. This looks like a lot of fun. Take a look at this, 90 seconds on this one. Put answers in when you get them. Ten more seconds. Okay, this question really is about reading carefully. It really is about reading carefully. We see that the average was 2.95. We see that the standard deviation is 0.6. And most importantly, we see that it is 1.5 standard deviations that we're looking for. Okay? How many of the grades are more than 1.5 standard deviations from the mean? So now we take 2.95 and we're going to add to this 0.6 times 1.5, which is 0.9. So 1.5 standard deviations is 0.9. So we're going to take this 2.95 and we're going to go plus and minus 0.9. And what that's going to end up giving us is 2.95 minus 0.9 is 2.05. 2.95 plus 0.9 is 3.85. Okay? So we're looking for anything outside of 2.05 to 3.85. We're looking for anything that's not within that range. So 2.05, 3.85, here's 3.9, that's too big. Here's 4.0, that's too big. So we have two of them. But wait a second. I know it says the word more, but we're also looking for things that are less than 2.05. So that's going to give us 1.8 and 1.9. The answer is going to be E. The answer is going to be E. We have to read this very carefully because what does it say? The easiest traps to fall into here are using one standard deviation instead of 1.5, which would leave you adding and subtracting 0.6. Or number two, and I think those who answered C may have done this one, taking the word more to mean only those numbers that are above plus 1.5 and not counting those that are below minus 1.5 standard deviation. So notice what this says and notice what we did. It says how many of them are more than 1.5 standard deviations away from the mean. This always means plus minus. So the careful reading is there. It always means you're more than 0.9, which is 1.5 standard deviations up, or you're more than 1.5 standard deviations below. So in this case, we're going to have four of those. Couple of great trap answers there to fall into, and the answer is E. So definitely, we have to read carefully. Now let's look at B. Another part of reasoning and quantitative reasoning means, yes, knowing the proper formulas and equations, absolutely, but also when to use each. Formulas are important and necessary tools for your success. The same way that a fire extinguisher is an important and necessary tool for fighting fires, right? If you don't have a fire extinguisher, you're probably going to have some difficulty. If you don't have a mathematical formula, you may find yourself in trouble. But here's the thing. A fire extinguisher does not put out fires. A person does. A person who knows how and when to properly use the extinguisher puts out the fire. You need both. You need the tool itself, and you need the knowledge to use it. And that's the same thing that we're talking about here on math. A formula does not yield the correct result to a GMAT question. A person who knows how and when to use that formula, that's what gets the correct answer. And by the way, luckily most of what's on this board here, I see some sort of three-dimensional situation down there, some sine curves up here. So most of what's on this board is not actually applicable to GMAT math. So that's always good. We're not going to do this question yet, but I just want you to quickly look at this. For each integer n greater than 1, a, n, denotes the sum of the integers from 1 to n. What is the value of a, 200? Okay? So think about what formula we can use when we come back to this. We're going to come back to this. I just want you to see this question looks complicated, and it turns out not to be. Okay? It turns out not to be. So we're going to come back to this one in a couple of minutes. Don't worry. Let's start with the formula for the average. This is one of the most important formulas in statistics, right? The formula for the average. Everybody knows this formula. The mean is the average. Mathematically, that means the sum of the terms divided by the number of terms is the average. So let's look at a question. I would call this an above average question, okay? Above average difficulty average question. Let me give you 90 seconds to look at this one. This is our third problem today. Take a look at this and answer choices. 10 more seconds. This is the closest thing to straight algebra today. And we got a bunch of correct answers on this. So this is just the average, right? So you're going to add these together. So you're going to do n minus 4 squared plus n plus 4 squared over 2 to get the average because there's two of them. Now, as everybody can see, the only way we're going to be able to simplify this is if we square each of these. So n minus 4 squared is n squared minus 8n plus 16. And n plus 4 squared becomes n squared plus 8n, again plus 16. We now add those two equations together. We have 2n squared, the minus 8n, the plus 8n drop out. 16 plus 16 plus 32. Put that over 2. Right? Now we divide each of these. Remember, when you're adding or subtracting, you have to do the same thing to both parts. Divide this by 2, also divide this by 2, and we now have n squared plus 16. Correct answer is C. Okay, that's an example. It's an above average question, but average questions like that are going to be pretty straightforward, and they're also going to be very few in number. Very few questions will give you the sum and the number of terms and ask you for the average, okay? So this equation right here that we just used, not going to be used that much on the exam. This is the question that you're going to use on the exam. Now, obviously, it's the same equation. It's just that you've moved the number of terms up here. But this is the cleaner way to think about this. I call this getting a tan. It's summertime right now. A lot of people are out in the sun. It's time to get a tan. Tan is the sum total, right? T for total, is equal to the average times the number of terms. This equation comes up even when you don't expect it. And so we're going to work on a few problems with this equation. So total is the average times the number of terms. Okay? Let's try using the tan formula on this problem-solving question. And there's another special, formula, trick, technique that I'm going to show you after you've looked at this problem yourself in 90 seconds. You probably have a way of solving this. I'm going to give you a universal way to solve any of these. 90 seconds on number 4. Ten more seconds. Okay, we're going to use the tan formula on this. We're going to say total equals average times the number of terms. Let me walk you through this one step by step. The average is actually pretty easy to get. The average is actually pretty easy to get. Whenever you have any sort of consistent spacing, consecutive integers, even integers, multiples of 50, whatever it is, As long as the spacing is consistent, you simply add the smallest plus the largest, divide it by 2. So 1400 divided by 2 is 700. I think you guys may have known that. That's something that quite a few people know. When there's consistent spacing, evens, odds, multiples of 3, integers, whatever it is, even if it's not integers, even if it's like 1.5, 3.0, 4.5, 6.0, something like that, even with something like this, the spacing is consistent. We're just increasing 1.5, right? You always add smallest plus largest and divide by 2. Smallest plus largest divided by 2. So that's going to be 7.5 divided by 2, and that's going to be 3.75. Oh yes, Amarpreet, the recording is always available. Yeah, from GMAT Club. They'll have that for sure. So smallest plus largest divided by 2 gives us an average of 700. Okay? The more difficult part, this is the part that challenges people more. How do I quickly, efficiently, always know the number of terms? It's a 3-step. It's really simple. You first of all just get the range. Always just get the range. Then you divide by the spacing. And then you go +1 for inclusive. Okay? Range divided by spacing +1 for inclusive works every time with every problem. Yes, there are certain ways to do this problem because it's even integers. I want to give you a formula that's going to work anytime that you're trying to get the sum or the total. So the range here is 750 minus 650, which is 100. We want to divide that by the spacing. Now the spacing is even numbers. And that's going to mean that we're going to divide by 2, and that's going to give us 50. And that would be answer choice B. But answer choice B is not correct because you always add 1 if it says inclusive. +1 gives us 51. So the number of terms is 51, and therefore the answer is C, 35,700. If they ever want to ask you the sum, you always just go smallest plus largest, okay, divided by 2, the average. Range divided by spacing +1 for inclusive. Now people say to me, well, David, what if it says not inclusive? Okay, what if they said 650 to 750 not inclusive? Well, if you want to be clever, you could say 51 minus 2, right? Because 650 no longer counts and 750 no longer counts because it's not inclusive. But I would prefer that when you get a great formula like this, when you get a great technique like this, you just apply it all the time. So here's what I would do. If they said 650 to 750 not inclusive, I would say, okay, that means 652 to 748, and now it is inclusive. You see what I mean? I would move to the next number that is inclusive so you can use the same formula every time. So let's have you guys try this same formula because guess what? This exact same formula is going to work. Not understood. Range divided by spacing +1, sum or average. No, it's neither the sum nor the average. Vampire. Vampire. It's neither the sum nor the average. It's the number of terms. It's the number of terms. Okay? To get the sum, we take the average times the number of terms. That's what the n is. And the number of terms is range divided by spacing +1. So let's try this again for just 60 seconds. 60 seconds, because now that you know exactly the steps, I bet you can do this in 1 minute only. Number 5. 5 seconds. I think we got as many right answers in 60 seconds on this one as we did in 90 seconds previously. So again, we're going to get that tan. Total is average times the number of terms. Now I made the numbers nice so that we could work with these numbers in 60 seconds. So the average is actually going to be pretty easy because it's 0 plus 700. Remember, 0 is a multiple of everything. So 0 is a multiple of 7. Okay? So the first multiple of 7 is 0, and the last multiple of 7 is 700. So we have 0 plus 700, which is 700 divided by 2 is 350. So our average is 350. Now, the number of terms, remember, range divided by spacing, and then it is inclusive, so it's plus 1 for inclusive, okay? The range is 700 minus 0 is 700. I told you I made these numbers a little bit easier so we could work with them in 60 seconds, right? So the range is 700. The spacing is 7 because it's multiples of 7. So every seventh number, right? So it's 700 divided by 7 is 100, and then it is inclusive, so it's plus 1. So there are 101 terms times 350. And you can tell that 350 times 100 is 35,000. And then 350 times 1 is 350. The answer is C, 35,350, which is almost the same answer we just had, right? 35,700 was the answer we just had. And now we have 35,350. Who knew that the sum of the even numbers from 650 to 750 was almost exactly the same as the multiples of 7 from 0 to 700? Okay, so we see how this applies when they're asking us for the sum. Okay, now, what about this problem I had you look at for a few seconds, like 10 minutes ago? Can you solve it now? So, realize how the tan formula and everything we just did applies to this. Understand that. 90 seconds. You guys don't seem to need 90 seconds. I'll just give you 10 more seconds on this. Okay, a bunch of correct answers in 1 minute. This is actually an official GRE question. This is actually an official GRE question. I also teach the GRE. If anybody's interested in that exam, we do that one at Veritas, and I'm the lead GRE instructor. So actually, I get asked this question a lot, okay? My GRE students ask me what to do on this question a lot because the explanation in the book, you know how the official guide to the GMAT, sometimes those explanations are way more complicated than they ever need to be. Well, this explanation to me, for this GRE problem in that official book, it's crazy. Basically what they say is this. You're told what the value of A100 is. And now you know that every term above that is this plus 100, right? And they go through like 7 different calculations to get to the correct answer. How about something a whole lot easier? How about we use the tan formula and we just ignore this A100 part. You know, the only reason I ever go through this A100 part is just to show the students the tan formula so they can apply it, but you already know it. So let's go straight to this. If we're looking for A200, that means we want every number from 1 to 200, right? So now we're looking for consecutive numbers. Well, this is going to be easy, isn't it? This looked like a difficult question at some point until we deciphered it and until we picked the right formula. And then most of you got this right in 60 seconds. So all we're going to do is we're going to say 1 to 200, right? So we're going to go 1 plus 200 is 201, divided by 2 is 100.5, and that's the average. So if we're going total is average times the number of terms, 100.5 is the average. And then we can so easily get the number of terms. And the number of terms is the range. Well, the number of terms is just 200. I mean, we don't even need to use the trick on this one. The number of terms is just 200 because it's, you know, from 1 to 200. I mean, we could use the other formula. We could say the range is 200 minus 1, which is 199. We could divide by the spacing, which is 1, because it's all integers, which is still 199. And then we could go plus 1 for inclusive. But however you look at it, you end up with 200 terms. So we have 100.5 times 200, and that is 20,100, and that is correct answer of D. Okay? If this problem was really easy for you now, I'm glad. That's what we're going for. That's what we're going for. Once you recognize and have the right formula, it is going to be easy. We just have to know when to apply those formulas, okay? So total equals average times the number of terms. Finally, here's a problem that can be solved very quickly using some logic and the right formula. Okay? So how about this one? Can we solve this one quickly? Number 7. All right, 10 more seconds. 10 more seconds on this one. So the average of, which is the, the mean of 16 students' first quiz score is 62.5. When one student dropped the class, the average of the remaining scores dropped to 64. What is the quiz score of the student who dropped the class? Is there anything about this that screams, I have to get the total and then subtract? This is what I'm talking about, logic. The most important thing on this question, and here come the correct answers, the most important thing on this question is to realize what it is you're doing. If you get the total of the 16 students, right? Total of the 16 students, Then you subtract the total of the 15 students. I mean, that clearly gives you the one student, right? The one student. You know, that's hilarious, Shrivam. Answer choice E is eliminated as the average is decreasing. As the average is increasing, right? The average is increasing. When you get rid of the student, the average increases. So that student can't be at a 70. So there's some logic. That's what I call problem-solving karate, when we're able to chop some impossible answers. Sometimes it's worth it to take a moment and to chop an impossible answer or two. And when is it worth it to get rid of some impossible answers? When you're not able to just work the question, okay? If you're able to just work this question, as so many of you seem to be, then, you know, it's probably not worth it to even eliminate some answers. But if you're down to the point where maybe you're going to have to guess or you're out of time, I mean, answer choice E is impossible, right? It can't even work. So the total of the 16 minus the total of 15 is one student. So the total of the 16 times 62.5, that equals 1,000. 16 times 62.5 is 1,000. And the total of the 15 is 64 times 15. And of course, it's easy to multiply 64 times 15. You multiply 64 times 10, which is 640. And you add half of that, which is 320. So you get 960. And then the average is 40. I mean, sorry, the remaining student is 40. Correct answer is C. So again, when you know the right tool, then the question becomes quite simple. Now, the third idea in terms of reasoning is you need to have some pure reasoning when either the formula fails, right? Or to check the result you get from the formula to make sure the result is logical, right? Or 62.5 minus 1.5 times 15. Yeah, absolutely. That's an even quicker way to do it. How about this one? Let's use some logic on this official GMAT data sufficiency question. Not too difficult, but not really a formula, mostly logic. Okay, some of you may have seen this question. Look at number 8. Ten seconds. Well, that took us the longest. I'm seeing some answers flood in now, but I think that took us the longest on that. There's only 3 possible answers to this. There's only 3 possible answers. 400, 475, or we don't know. Does that make sense? If this was like problem solving and you had to pick an answer, the answer has to be 400, 475, or we don't know. Because either it's going to be the upper shelf book with the greatest number of pages, or it's going to be the lower shelf book with the least number of pages, or else you won't be able to figure it out. And the correct answer to this question comes down to C versus E very quickly. Because obviously, if you just have statement 1, you only know there are 25 books. If you just have statement 2, you only know there are 24 books. Okay? And you don't know what's going on with the other shelves. The median is the middle. The median, when you drive down the highway, that concrete barrier, or I live in Vermont, so we don't really have concrete barriers. We have like grass with wildflowers, in between our interstates. So our median is like a nice place. In downtown Los Angeles or New York, it's a concrete. That's the middle. That's the median, right? So we're looking for the middle. Well, you need to know how many total books there are, first of all. So there are 49 total books. But only if you take both statements together do you know that there are 49 total books. Now you're looking for the 25th book, which will be the middle of this, right? So if you have the 25th book, you have 1 through 24 below. You have 26 through 49 above, and in both cases, 24 books below, 24 books above, and that's going to be the middle book. And that middle book is going to be on the upper shelf. And so we're looking at the upper shelf, and we're looking at 400 pages. Okay? We're looking at 400 pages. And that's because you can tell that every book on the upper shelf has fewer pages. Remember what I said about reading carefully. We can deduce from this. They don't tell us. We can deduce that every book on the upper shelf has fewer pages because the greatest number of pages is 400. We can deduce that every book on the lower shelf has more pages than anything on the upper shelf because the lowest number is 475. So that means the longest book on the upper shelf. Longest book on the upper shelf equals the median. So the median is 400. And it is sufficient, and the correct answer is C. Okay? It is sufficient, and the correct answer is C. Longest upper shelf is the median. A little bit of logic there, right? Where's the formula? I mean, you have to know what a median is, right? But logic, reading carefully. This is where statistics moves. This is where the entire GMAT moves. The better you get at anything with a formula, the more they try to have something with no formula. The more they try to hide something. Like the first 2 questions we did. The data sufficiency question about the reservoirs. That was tricky. Now let's try this Veritas problem solving. Let's take a look at this one. This is an interesting one. Logic, 90 seconds. This is a homework question from the Veritas Statistics book, Statistics and Combinatorics. And you guys are making me go back and check. Like I know it. I know I have the right answer, but I'm not seeing that answer up here. So here's a question with some logic that appears to be less difficult than many other things we've done, and yet I don't see any correct answers up here. So look what we're trying to do. We're going to add a digit from 0 to 9, right? We're going to add one digit, and that digit is going to be from 0 to 9. What's the probability that the median of the set will increase while its range remains the same? Okay, so we're going to put this over 10. A probability is always a fraction. So we're going to put this over 10. 10 is the number of digits we have, right? 0 through 9. What we need to have on top is we need to have the number that will increase the median but keep the same range. We want to increase the median but keep the same range, right? So what's the range? It doesn't matter. It doesn't actually matter what the range is. If we want the range to remain the same, we only have to do what? We only have to not have any number that's smaller than 2 or bigger than 8. Does that make sense? Right? The number that's smaller than 2 or bigger than 8. So anything from 2 to 8, let's just call this x, right? X can be from 2 to 8. X can be from 2 to 8 and satisfy the first part. The first part is to keep the range the same. So that means we could have 2, 3, 4, 5, 6, 7, or 8 to keep the range the same. Only 0, 1, and 9 would change the range. So we have all of these numbers, but we have a second thing we have to do. We have a second thing. We also must increase the median. We need the median of the set to increase. Well, what's the current median? Well, we have we've put the numbers in order. So the median is going to be the average of the middle two, which is 5. The median right now is going to be 5, right? The average of the middle two. So if we add 2, 3, 4, or 5, the median does not increase. In the case of 2, 3, or 4, it decreases. Right? So this would be a lower median. 5, the median would stay the same, but 6, 7, and 8. Okay? So, and you were really close, right? 6, 7, and 8, right? Will keep, the median will increase, the range will stay the same. So we have 3 out of 10. We have 30%. And we did get some correct answers after I said that we didn't have any. Okay, so Shivam, Anuat, and Shiara also had B as well before I even started the explanation. So yes, we did get some people with the correct answer, but it took longer. Okay, not a hard question, not a formula to apply, not an equation to memorize. Now, you need to know some number properties. You need to know about medians, but this is essentially some sort of a probability question, but really a statistics question. Okay, so logic, reading carefully, details. This is the kind of thing that we need to have. And let's do just as a final question. This is our 10th question. Okay. Oh, good, perfect. See, 90 seconds on that is great. Excellent. This is a question that actually, strangely, when I teach, the classes, and this is lesson 10, right? So we've been at it for 5 weeks when I teach this question. This is actually from the lesson. Most people miss this. So that's a challenge for you. All right? 90 seconds on number 10. This isn't hard, right? 90 seconds. All right, we'll stop right now. See, you guys always surprise me. On the questions that I think that more people are going to miss, everybody gets it right. On the questions where I think everybody's going to get it right, that's why you can never quite tell the difficulty. Okay? That's why you can never quite tell the difficulty on a question. So if you get the tan right here, we're going to do this twice. We're going to get the tan twice. Okay, the first time we're going to go five numbers, average of 6.8, and that's going to be 34. The second time we're going to go five numbers at 9.2, and that's going to be 46. So that's an increase of 12. Okay? That's the increase of 12. Now, here's how you could very carefully think about this. If you're going to have an increase of 12, this is what you did. You went from five numbers. Let's call those numbers A, B, C, D, and X. Okay? So five numbers, A, B, C, D, and X. This totals to 34, right? This totals to 34. We have the same five numbers, A, B, C, D, and X, but now we're multiplying X by 3. So now it's A plus B plus C plus D plus 3X. Again, we're going straight to the total. It seems like every stats question that involves anything to do with an average, you go straight to the total. It's not the average you want, it's the total you want. And the total here is 46. So as we quickly look at this, 46 does not equal 34. This is not an equation, but this is. (34 plus 12 is 46. Therefore, A plus B plus C plus D plus X plus 12 is equal to A plus B plus C plus D plus 3X. And four of those numbers are the same, A, B, C, and D. And so now you simply have X plus 12 equals 3X, and we have 12 equals 2X, and we do have 6 equals X. So everybody who picked 6, absolutely correct. The way that people miss this with the algebra is they say 3X equals 12, so X equals 4. Just remember, you don't remove X and replace it with 12, you add 12. So read carefully on that. There's another way to look at this, which is from arithmetic. So if you think the answer is going to be D, you take that 4.0, you multiply it times 3, and you get 12. That's an increase of 12, right? No, because you started with 4. So it's 12 minus 4 equals an increase of just 8. So that's the arithmetic way. 6.0 times 3 is 18 minus 6. That's an increase of 12. That's the correct answer. It's funny that nobody, that almost everybody got that one, and very quickly as well. So as you've seen, more than ever, the GMAT quantitative section is about reasoning. And you could see it in the chat box. The questions that I gave you that were more formula dependent, that were clearer in terms of what they were asking, maybe the math was more difficult, but the question was clearer in what was being asked. The answers came flooding in within 90 seconds. Correct answers. As soon as we got to something data sufficiency, as soon as we got to something that didn't have a clear formula, here comes 90 seconds, not a lot of answers. Maybe incorrect answers, right? Maybe incorrect answers. Yeah, it would be that simple, Arunda. It would be that simple, yes. 3a minus a is 12. A is 6, yes. You need to know the formulas, but you also need to know how and when to apply them and what to do when logic is required. Okay? So read carefully, notice the details, formulas and equations, know when to use them, and have some pure reasoning at the ready, because oftentimes questions are going to require that. Make the logical choice. This is what I want to tell you, okay? Let me get my pun out there first. Make the logical choice and follow the statistical reasoning. The stats show that Veritas Prep offers the best test preparation, right? I got to get my puns out there. What I do want to mention to you guys is that if you did enjoy this one, sign up for a free trial. Attend the first session of a Veritas Prep GMAT course for free, the first 3-hour session. And, you know, we tend to go through a lot of different things in there, including most, you know, of the verbal section, including data sufficiency, problem solving. So that 3 hours gives you a good introduction, some good tips that you can check that out. The stats are, you know, 99th percentile career instructors. I mean, I've been with Veritas for 15 years. So when we say career instructors, that's what I must have started when I was 18, right? No. Think like the test maker, strategic curriculum, best in-class live online platform, daily office hours, constant homework help. Phone number there, veritasprep.com. There's a picture of me. That's hilarious, right? So I just want to mention my upcoming classes in case you want to attend my first session. Now, I'm not starting another one until August 7th. Then August 24th, October 3rd, November 18th. There are also options with other instructors. So take advantage of it. Attend that first 3-hour session. See if you like it. You get a lot of tips just within that, you know, just within that 3 hours. So veritasprep.com, lots of options there. Just some options there with me. It's kind of funny to have a big picture of yourself up there. It's kind of funny. So some of these are Saturday and Sunday, 10 a.m. to 1 p.m. That's usually better internationally. 7 p.m. to 10 p.m. Eastern time, usually not very good for international folks. That's like, you know, 3 a.m., you know, 4 a.m. for some people. So we got some Saturday, Sundays coming on there. All right, so thanks, everybody. Let me know if you have any questions for me. Master the GMAT stats with the logical approach. Okay. Oh, thanks. Thanks. You like the suit. Well, that's the best they could do. That's the best they could do. So thanks, everybody. Check out the prior seminars that I've done. The 10 toughest sentence correction, the 10 toughest critical reasoning. Recently, we just did tips that actually take longer. We just recently did time-saving tips that actually take longer. So just go look at GMAT Club, look at Veritas, some great seminars there. GMAT Club has great seminars from, you know, all kinds of folks, but look for the Veritas ones, you know. Maybe see a few of mine. So thanks, everybody, and we'll go ahead and end this one now, and we'll see you again in a few weeks, and we'll do another one of these, and best of luck. It's a little bit me. It's a little bit me. Thanks, everybody.